Hello and welcome to a trickier example of the intersecting chords theorem. Okay, so here's the question, that we can see it. Circle with two chords that intersect. They're called PQ and RS in this example, so we can't use our formula, but we can use our slogan. We're told RS is 12 and RX is 6, and we want to find PX. So the first thing we should do is we should label on the things that we're told are useful. So we're told Rx is 6, that's a circle to crossing point length, so that's useful. And we're not actually told Sx, we're told Rs, so that's the first little trick. We have to note that that's also 6. And then things start to go wrong. We're told the total length PQ, and we want to find PX, so that's unknown at the moment, but so is QX. So here is the key step. If that length is an unknown thing, little x, I hope that's not too confusing, having a little x for a length and a capital X for a point, then this length here must be, because PQ is 13, 13 minus x. And once we've got those written down, we can plough in with our slogan, circle to crossing point times circle to crossing point on the vertical chord. So that's 6 times 6. They happen to be the same, is equal to circle to crossing point is x from that part of the circle and 13 minus x here. I'll write that with a bracket rather than just a times. Okay, that's a good piece of algebra there. That's it. What is this? I'll expand out the bracket. So 36 is equal to 13x minus x squared. And what you've discovered is that there's a quadratic equation. And that happens an awful lot in these intersecting chords theorem problems, so don't panic. Just go ahead, engage the algebra part of your brain, and solve the quadratic equation. I'll move everything onto the left-hand side to keep the x squared positive. X squared minus 13x plus 36 is equal to 0. We'll hope and pray that it factorizes. And actually this one does. Two numbers whose product is positive 36 and whose sum is negative 13. Positive product, so either both positive or both negative. Negative sum, so both negative. And 6 and 6 doesn't work. 3 and 12 doesn't work, but 9 and 4 does work. Minus 4 and minus 9. There we are. So x is equal to 4 or 9. So x, remember, was px. Probably answer it in that way. And there are two possible answers, which seems a bit confusing, and admittedly the question maybe should have said find the possible values of px, but you'll just notice that if px is 4, then this one's 13, so the lengths on the chord are still 4 and 9, and if px is 9, then this length is 4, so either way you get two lengths, 9 and 4. It's not that surprising.